Okay, moving on in OLI Mod 24, we are on to question number 4 that goes along with it. Did I get this question on page 159? It says, suppose the engineers in the previous example want to make a 99% confidence interval. Now, I haven't looked at that previous example here, but it doesn't matter. This is fine. They plan to use the same sample of 45 cables. So part A says use the applet to find the critical t-value they will use in the computation of the margin of error. We're going to go ahead and answer that question, but we're going to use StatCrunch, not the applets that they're using in OLI. We have access to StatCrunch. It's a very powerful data analysis tool, so we're going to use that. So let's move on here to part B first. So we're going to construct the 99% confidence interval based on the sample from the previous example. And here were the sample results that were included. Notice with this sample size of 45, we know that the sampling distribution of sample means will be normal. However, since we are only given the sample standard deviation, we will need to use the t-distribution. So we will use that. For making a confidence interval, we know that this will be centered at our x bar value of 768.2. And then we are finding the left and right endpoints that enclose 99% of this curve. All right, so we're going to go to StatCrunch for this. Over here, we're picking stat, t-stats, because we're using the t-distribution. We have one sample, and we have the summary of that sample, not the data. Our sample mean is 768.2. Our sample standard deviation is 15.1. Our sample size is 45. We have a confidence level of 0.99. Click compute. Okay, so here is the standard error or the standard deviation of this t-distribution. We had a sample size of 45, so there's our degrees of freedom, 44. And here are the upper and lower limits for our confidence interval. So let's round off to one decimal place, 762. Let's do 2 actually, 0.14 up to 774.26. Okay, now from this, we will be able to go back and find this t-value that they're looking for, okay? The t-value is the t-score at this right-hand endpoint. So what we need to find is how many standard deviations is it from the center to this right-hand endpoint. That number of standard deviations is the t-score. That's definition of a z-score, and t-score is exactly the same thing here. So let's think about this calculation, okay? The right-hand endpoint is 774.26 minus the center is 768.2. That'll give us the total distance from center to this right-hand endpoint. We want to know how many standard deviations is that. So what we need to divide by is not the standard deviation of the sample. We need to divide by the standard deviation of this distribution, which StatCrunch gave us over here. The standard error is 2.25. So this really is the same formula we used for z-scores. Just to remind us, z-score is x minus x bar over s. But if we think about what these things mean, x is our piece of data. We're trying to find the z-score for the right-hand endpoint. So that's our piece of data. Minus x bar is center. Center of this distribution is 768.2. Divided by standard deviation. Well, standard deviation for this distribution is the 225 that StatCrunch gave us. So our t-score here, if I round off to 3 decimal places, just because I see that's what is in OLI, I get 2.693. And OLI has the same choice. They've got a different number here in the 3rd decimal place, and it's just due to rounding error. So this now is our answer for part A. So what we have found out now is that actually for any 99% confidence interval using a t-distribution, the endpoints are going to be 2.693 standard deviations from center. But of course, the easiest way for us to get these endpoints is just to put our information in StatCrunch and go from there. Okay, so part C is a more general question. In general, increasing the confidence level does what to the margin of error? Okay, well, let's think about this for a second. Let's say I have some confidence interval. Here's the center, and this was done with 90%. So the margin of error is the distance from the center to either of the endpoints. So that distance left and that distance right, those are each the margin of error. Now, if I increase that to, say, a 99% confidence interval, if I need to increase the confidence, I'm increasing the area. That means that these endpoints have to move out. So now the margin of error, is this distance. It's still the distance from the center to the endpoints, but now that distance has increased. So increasing the level of confidence also increases the margin of error, which is then a bummer, right? Those are opposing forces. We would like to be more confident. That's a good thing. But increasing the margin of error means that we are less precise, which is a bad thing. But remember, if it's available to us, the one thing we can do to combat this is increase our sample size. Increasing our sample size, if you can, right? There's lots of constraints, there's money, there's manpower, there's all of that. But if you can increase your sample size, your standard error will decrease, and that will pull these endpoints closer into the center.